In parts 1 and 2 of this volumetrics series, we demonstrated the dug-in site base module geometry tool, which makes a fast volumetrics calculation from two surfaces and is located in the map view. The more advanced explorationist module, Volumetrics, can be used to calculate gross rock and hydrocarbon volumes from multiple surfaces, contacts, and other optional scale factors. The 3D view is recommended to visualize the inputs to the volume calculation. This final part of the Volumetrics series visualizes the three-dimensional bodies they were calculating volumes for. The geometry that we will consider has a top structure and a base structure. Flat contacts have been shown earlier in the series, and so dipping oil and gas contacts will be introduced in this workflow. Flat and dipping surfaces for visualization and calculations can be made using horizon maths. In the map view operations, horizon maths add the structural horizons as inputs. Divide one of the horizons by itself to return the value of 1. Multiplying the constant horizon by the contact value of 3010 meters will create a flat contact horizon at this value. A dipping horizon uses the same basic formula, but adds a laterally varying value such as x and y, or, as in this example, inline or crossline. By subtracting 1500 from the crossline value, it will create a hinge point of 3010 meters at crossline 1500. Dividing the number of crosslines by 10 will scale the surface to give a final dip of 50 meters across 500 crosslines. The results can be seen in the 3D view and also as a cross-section in the section views. Volume maths can be used to define a value in each sequence of the reservoir. The basic calculation uses a comparison if statement to fill the space between horizons 1 and 2 with a constant value of 3. The sequence volume can be selected in the section view and displayed as a colour fill from top to base structure. A more complex comparison statement can be created that includes the dipping contacts as well as the structure to create multiple reservoir compartments for water, oil and gas. The same volumes can be displayed in the 3D view as sections through the data. Using the volume visualization, the sequences can also be rendered as a 3D volume. Adjusting the 3D visualization filters, each sequence can be displayed by itself for a clear image of the reservoir shape. Here is the oil section. And here is the gas cap. The body detection process can now be used to determine the gross rock volume of each compartment, using the sequence numbers as a cutoff. You might be wondering why the volume has a blocky, terraced look about it. This is due to the sample sizes used in the volume maths output. For a smoother volume, simply reduce the inline crossline spacing to 1 and the Z increment to 1 in the volume maths process. If the volumes look good and the numbers are economic, it's time to start drilling. If you have questions or would like to discover more, then visit our website at www.dug.com. And remember, have fun with Insight.